In some rational expressions, it is possible to get something called a slant asymptote. And that is an asymptote that goes at an angle like this. Okay? So this is called a slant asymptote, or sometimes called an oblique asymptote. So when does this happen? This happens when the degree of the numerator is 1 degree higher than the denominator. So what that ends up happening is, when we talk about slant asymptotes, they're the same as horizontal asymptotes, and they represent endpoint behavior. So what's happening way out at infinity. So we're worried about what's happening out here, not what's happening locally, but way out here. So as x gets really, really big, what ends up happening is these two terms relative to x interact in a way that gives us the endpoint behavior. So how do we find the equation of the slant asymptote? Well, we find it by long division. And I'll show you what happens here. So we end up with 2x squared plus 5x minus 1 divided by x plus 1 is going to give us a quotient of 2x plus 3 and a remainder of 4. So I'll write out the long division here. So we have x plus 1 going into 2x squared plus 5x minus 1. And so to do the long division here, we get 2x squared, subtract, we get 3x minus 1, bring that down, plus 3, so we end up with x plus 3x, x plus 3, and our remainder works out to be negative 4. Okay, so we end up with this quotient here. That's our quotient, and our remainder is negative 4. Now, why is it that this quotient happens to be the equation of that line? It's to do with this endpoint behavior. As x gets really, really big, this expression here looks like this. So this is equivalent to, if I divide this, I get 2x plus 3. So if I use my division statement, it's going to be the quotient plus the remainder divided by the divisor. This is my expression. These are equivalent expressions here and here. And as x gets really, really big, what ends up happening is the graph starts behaving like 2x plus 3, because this expression essentially tends to 0. So the limit as x goes to infinity or negative infinity of negative 4 over x plus 1, the denominator gets really, really big. So essentially this term here becomes insignificant. So this is relatively insignificant. So the graph starts to behaving like the 2x plus 3 equation. Thus it becomes asymptotic with that purple line. So again, this happens when we have the numerator degree is 1 bigger than the denominator, and these do not cancel out. Okay, this expression in the numerator does not share any common factors with the denominator, and we end up with this slant asymptote. And we can find the equation of the slant asymptote through long division.